Hi, myself Dr. A. Rushi Kesava, Associate Professor of Mathematics, Department of Freshman Engineering, Marri Laxman Reddy Institute of Technology and Management, Hyderabad. So, last class we already discussed. See, already we discussed last four classes: introduction of the eigenvalues and eigenvectors, properties of eigenvalues, Cayley-Hamilton theorem, and some of the properties of Cayley-Hamilton theorem like inverse matrix and powers of the matrix, find the inverse and powers of the matrix also. Okay. In previous classes, we have already discussed some diagonalization of a matrix. Okay. So here, see this definition of the diagonalization of a matrix, similarity of a matrix. Next, of the procedure diagonalization equal to, that is the diagonalization method means D equal to P inverse AP. P inverse AP equal to D. And model matrix and spectral matrices. Okay, we have discussed some properties of diagonalization and how to find power of the matrix by using diagonalization. That is A power n equal to P into D power n into P inverse. Okay. So now we have discussed the problems. Okay. In this class we have discussed the problems. Okay. You see that here the problem is determine the model matrix P of the matrix A is 1 1 1 0 2 1 minus 4 4 3. Okay. And diagonalize the matrix and also find the matrix A power 4. Okay. So first of all, we have to show the diagonalization means first of all we have to find eigenvalues of the matrix and eigenvectors. After that we can make model matrix. Okay, that is P equal to x1 x2 x3. Okay, so after we can checking diagonalization method, D equal to P inverse AP. Okay, so let us see. Now we have to find eigenvalues. Okay, okay, write down given matrix. You see that given matrix A equal to 1 1 1 0 2 1 minus 4 4 3. This is the given matrix. Now we have to find the eigenvalues. Before find the eigenvalues, just we can write the characteristic equation of the matrix. Okay, write down the characteristic equation is that of A minus lambda I equal to 0. Okay, that of A minus lambda I equal to 0. So we can write the that of A minus lambda I is 1 minus lambda 1 1 0 2 minus lambda 1 minus 4 3 minus lambda equal to 0. This is the that of A minus lambda I equal to 0. Now find the determinant of the matrix. That means we can get a cubic equation. Okay, third degree equation. Okay, now solve the determinant. Okay, that is 1 minus lambda into first row first column eliminated, applying AD minus BC. Okay, already we know that is 2 minus lambda into 3 minus lambda minus 4. Next, minus 1 minus of second column first row is eliminated, applying AD minus BC method. Okay, that is 0 into 3 minus lambda 0 minus of minus 4 into 1 is minus 4, minus minus plus. Okay, plus again plus 1 into last row first row last column eliminated, applying AD minus BC method. Okay, 0 into 4 is 0 minus 4 into 2 minus lambda minus minus plus 4 into 2 minus lambda equal to 0. Okay, solving the equation, that is 1 minus lambda into here multiplying these terms, 2 3s are 6 minus 2 lambda minus 3 lambda plus lambda square minus 4, here minus 4, Here simply to multiplying 2 4s are 8 plus 8 minus 4 lambda equal to 0. Okay. Again simplification 1 minus lambda into this is you can write lambda square minus 2 lambda minus 3 lambda minus 5 lambda and 6 minus 4 is 2. Okay. And here minus 4 plus 8 is plus 4 minus 4 lambda equal to 0. Okay. Again we can simplifying first multiply by 1 this term into 1, that is lambda square 5 lambda plus 2. Again this same term multiply by minus lambda. Okay. That is minus lambda cube minus minus plus lambda square minus 2 lambda minus 4 lambda plus 4 equal to 0. Okay. So finally the lambda cube terms are only 1 minus lambda cube. Next lambda square terms, lambda square 5 lambda square 6 lambda square plus 6 lambda square. Okay. And lambda terms minus 5 lambda, here minus 2 lambda minus 7 lambda minus 4 minus 11 lambda. That is next the constants are plus 2 and plus 2 plus 4, that is plus 6. Okay. Multiplying the entire term by minus sign. Okay, we will get lambda cubed minus 6 lambda square plus 11 lambda minus 6 equal to 0. Okay, lambda cubed minus 6 lambda square plus 11 lambda minus 6 equal to 0. This is third degree polynomial. Okay, so you can using any synthetic method or also using scientific calculator, we can get the roots. Those roots are the eigenvalues. Okay, so I thought that the values are lambda equal to 1, 2, 3. Okay, the eigenvalues are 1, 2, 3. Okay, that is therefore the eigenvalues are characteristic roots. Roots are 1 comma 2 comma 3. Okay, that is also using scientific calculator also. Okay. So now we have to already find the eigenvalues. Now we have to find the characteristic that is eigenvectors. Okay, characteristic vectors. Okay, next. So now find the eigenvector corresponding to the eigenvalue lambda equal to 1. Therefore first one, that is eigenvector for lambda equal to 1. Okay. So consider matrix of A minus lambda I into X equal to 0. Okay, that is the system of the matrix. Okay. So that implies okay, A minus lambda I. The matrix A is 1 1 1 1 0 2 1 minus 4 4 3. Okay. Okay, write down 1 minus lambda 1 1. Next 0 2 minus lambda 1. Next minus 4 plus 4 3 minus lambda. X is simply to write x1 x2 x3. 0 means 0 vector, 0 0 0 vector. Okay, now substitute lambda equal to 1. Okay, put lambda equal to 1, then okay, write down substitute lambda equal to 1. 1 minus 1 0 1 1. Next 0 2 minus 1 1 1 minus 4 4 3 minus 1 2 into x1 x2 x3 here 0, 0, 0. Okay, that is homogeneous system. Okay, now solving this equation. Okay, so by using any echelon form. Okay, applying row transformation, convert into echelon form. Okay, just for fun. So already this is 0, this is 0. Side, just to change row 1 here, R1 and R3 are interchange. Okay, for our convenience, R1 interchange R3. Okay, R1 interchange R3. Okay, we can write -4, 4, 2. Okay, 0, 1, 1, 0, 1, 1. Okay, x1, x2, x3, 0, 0, 0. So already this is all already 0. Second row first element 0, third row first element 0. We can make 1 is to 0. This one will be 0. Okay, so using R2, that means second row. Okay, that is R3 implies R3 minus R2. Okay, that is -4, 4, 2, 0, 1, 1, 0, 0, 0. Okay, here x1, x2, x3, right side is all are 0. Okay, so now write the system of equation. This row into column equal to 0, second row into column equal to 0, third row into column equal to 0. Okay, so write down. Now expand the system of equation. That is first row, first column, right side x. Okay, -4x1 plus 4x2, 2x3 equal to 0. Second one is x2 plus x3 equal to 0. So here number of variables are x1, x2, x3. 3. Rank of the matrix is 2. That is 3 minus 2, one independent variable. Okay. Already we know, we already discussed eigenvalues and eigenvectors problems. Here n equal to 3, r equal to 2 rank. Therefore, number of independent variable is n minus r, 3 minus 2 equal to 1. Now we are taking one independent variable. Okay, let us assume that let x3 equal to k. That is the independent variable. Okay, substitute x3 in the equation. Okay, that is x2 plus k equal to 0. That is x2 equal to minus k. Okay, that is. Now this two x2 and x3 values substitute in this equation. Okay, so here also we can write, that is -4x1, 4x2, 2x3. Okay, cancellation by 2. Okay, that is -2x1 plus 2x2 plus x3 equal to 0. Okay, now substitute the values. -2x1, x2 is minus k, that is -2k plus k. x3 is k, already we know x3 is k. Okay, that is x3 equal to k. Okay, simplifying this one, -2x1 minus 2k plus k minus k. So finally 2x1 equal to minus k. Okay, x1 equal to minus k by 2. This is x1. Okay, this is x1. So already, so now to find the values of x1, x2, x3, that is therefore the vector x1, x2, x3 is equal to, x1 is minus k by 2, x2 is minus k, x3 is k. Okay, now just take common values of minus k by 2. Okay, minus k by 2, that is 1. This is minus k by 2 means this is 2, this is minus 2. So to multiply this vector minus k by 2, we will get the same one, minus k by 2 minus k, okay, that is minus k, that is yes k, okay, 1 2, that is 1 2 minus 2, okay. So finally the eigenvector x1 is 1 2 minus 2, okay. That is the first eigenvector of the eigenvalue lambda equal to 1, okay. Next we have to find next eigenvector for lambda equal to 2, okay. Okay, you see second one. Eigenvector for lambda equal to 2, okay. Same thing, right? The characteristic equation, consider a minus lambda I into x equal to 0, okay. To write the matrix is so that is 1 minus lambda 1 1 0 2 minus lambda 1 minus 4 4 3 minus lambda into x1 x2 x3 and 0 0 0, okay. This is the system of the equations, matrix equation, okay. Now substitute lambda equal to 2, okay. Put lambda equal to 2, then the matrix, okay. That is substitute the values. 1 minus 2 is minus 1 1 1 0, 2 minus 2 0 1, here minus 4 4, 3 minus 2 1, x1 x2 x3 0 0 0, okay. That is so this one is already 0. Just interchange r2 and r3 rows are interchange, okay, for our convenience, okay. Write down r2 interchange r3, okay. That is minus 1 1 1 minus 4 4 1 0 0 1, okay. These are all same, x1 x2 x3 as right side equal 0 0 0, okay. Now applying already already third row first element second element will be already 0, so we can make second row first element will be 0, okay. Now applying row 1 by 4, multiplying row 1 by 4 and subtracting, okay. That is so r2 implies r2 minus 4r1, okay. That is so here minus 1 1 1 multiplying by minus 4, that is plus 4 minus 4 0. Next multiplying by minus 4 plus 4, it is also 0, okay. Minus 4 plus 4 is minus 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 plus, this is also minus 4 plus 4 0. This is minus 4 plus 1 is minus 3, okay. Next 0 0 0 0 1, okay. This is 0 0 1 0 0 1. So we can also obviously here x3 equal 0 x3 equal to 0 to make any one to write that. First of all just by applying r3 we can make already, so multiplying r3 by 3, multiplying by 3 and adding just add this row 2 and row 3, this will be definitely 0, okay. That is so here see that I will write r3 implies 3R3 plus R2. Okay, that is 3 plus 3 minus 3 is 0. So already, so minus 1, 1, 1, 0, 0, minus 3, 0, 0. This is also 0. So definitely x2. Rank is 2. Number of variables are 3. Okay, so write down. So we can write the equations of this matrix is minus x1 plus x2 plus x3 equal to 0. Okay, and last one, second one is minus 3x3 equal to 0. That implies x3 equal to 0. So x3 equal to 0. Substitute the first equation, that is minus x1 plus x2 equal to 0. So variables are 2, equations are 1. Okay, already we know number of variables are 3, that is n equal to 3, rank equal to 2. Number of independent variables are n minus r equal to 3 minus 2 equal to 1 independent variable. So let us assume x2 equal to k, that is let x2 equal to k. Now substitute this equation. Okay, minus x1 plus k equal to 0. That implies x1 equal to k. Okay, x1 equal to k, x2 equal to k, x3 equal to 0. Therefore, the vector x1, x2, x3, that is x1 is k, x2 is k, x3 equal to 0. So take common of k, that is 1, 1, 0. So 1, 1, 0 is the eigenvector. Therefore, the eigenvector x2 of the eigenvalue lambda equal to 2 is 1, 1, 0. Okay, this is the second eigenvector, that is 1, 1, 0. Now we have to find third eigenvector corresponding to the eigenvalue lambda equal to 3. Okay, now find. Okay, third one. Eigenvector for lambda equal to 3. Okay, now write down, consider the system of equations, system of the matrix A minus lambda I into x equal to 0. Okay, that implies we can write the matrix 1 minus lambda 1, 1. Okay, 0, 2 minus lambda 1, minus 4, 4, 3. Capital X is, that is x1, x2, x3 of the column matrix. Right side is 0, matrix means 0 column matrix, 0, 0, 0. That is homogeneous type. Okay. Okay, now substitute the value lambda equal to 3. Okay. So simply to write lambda equal to 3. Then the system is, okay, write down. 1 minus 3 is minus 2, 1, 1. Next 0, 2 minus 3, minus 1, 1, minus 4, 4. Next 3 minus 3, 0. Okay. And x1, x2, x3. Here 0, 0, 0. Okay, that is now make using row transformation. Okay, already this is 0. We can make it 0. Third row, first element, second element will be 0. Okay, to make the zeros. Okay, so applying that is first term. Okay, simply row transformation. So multiplying row 1 by 2. Okay, and subtracting. Okay, that is R3 implies R3 minus 2R1. That is first one. Second one is same thing. So applying this one. R3 implies, okay. Okay, no problem. I can first of all applying this one only. Okay. So first of all we can apply this one only. minus 2, 1, 1, 0, minus 1, 1. Okay. Applying the row transformation. R3 minus 2, R1 plus 4 minus 4, 0. Next minus 2. 2 into minus 2 plus 4 plus 2. Next minus 2. Okay, that is. Again to make it 0, this one. Okay, that implies we can write R3 implies multiply row 2 by 2. Okay, just adding. So R3 plus 2 R2. Okay, entire second row multiply by 2. Okay, and adding row 2 and row 3. Okay, just that is minus 2, 1, 1, 0, minus 1, 1. This is already 0. So just adding, multiply by 2, plus 2 minus 2, 0. Here also plus 2 minus 2, 0. Okay, this is the, so the rank of the matrix is last row is 0 means rank is 3, rank is 2. Number of variables are x1, x2, x3, n equal to 3. Okay, so write the system of equations is minus 2x1 plus x2 x3 equal to 0. Okay, second row multiplying second row is minus x2 plus x3 equal to 0. So number of variables n equal to 3, rank equal to 2. Number of independent variables n minus r equal to 3 minus 2. One independent variable, that is we can assume that k. Okay, that is let x3 equal to k. So substitute x3 equal to k into this equation. Okay, that is minus x2 plus x3 equal to 0. That implies x2 plus k equal to 0. That implies x2 equal to k. Okay, that is already x3 equal to k. Now we can find x2 equal to k. Now substitute x2 and x3 in this equation. Okay, first equation. The first equation is minus 2x1 plus x2 plus x3 equal to 0. Okay. Now substitute the values x2 and x3. Okay, that is minus 2x1. Both are k's. x2 is k, x3 is k. Okay. Minus 2x1 plus 2k. 2 cancel. 2 cancel. Therefore, x1 equal to k. Here x1 is also k. x1, x2, x3 all are same values, that is k. Okay. Therefore, the matrix eigen vector x1, x2, x3 all values are equal, k, k, k. Take common factor of k. The eigenvector is 1, 1, 1. Okay. So finally, the crowd eigenvalue of the eigenvector is x3. x3 is 1, 1, 1. Okay. So yeah, we have to finish the eigenvectors x1, x2, x3. Now write the model matrix. Model matrix that is x1, x2, x3, matrix of x1, x2, x3. Okay, you know the model matrix P equal to x1, x2, x3. So write the column wise in eigenvectors. Okay, that is the model matrix.